Have you ever looked at a solar power setup and just wondered if you could ditch the heaviest, most expensive part, the battery? Well, today, that's exactly what we're diving into. We're going to figure out how you can run your stuff directly from solar panels. Let's get to it.
So let's just ask it straight up, the big question. Can you actually run solar panels without a battery to store all that juice? Is that even a thing? And the answer is yes, you absolutely can. But, and you knew there was a but coming, right? It is nowhere near as simple as just plugging things in. You've got to get the technical details just right, or things can go very wrong. I love this analogy because it just makes so much sense. Think about it. Solar power is like water flowing from a spring. A battery, that's your giant water tank, your cistern. It gives you a buffer. Without that tank, you are totally dependent on the live flow. The amount of power coming from your panels has to be more than what you're using at that exact second. This idea is the key to, well, everything else we're about to talk about. All right, let's start at level 1. This is the absolute simplest way to do it, but as you can see, it's also the riskiest. This is called a direct connection, and it is exactly what it sounds like. You literally take one solar panel, which usually puts out about 18 volts, and you wire it straight to something that runs on 12-volt DC power, like a small fan or a pump. So what's the pro here? It's ridiculously easy to set up. But the con? Oh, it's a big one. That 18 volts from the panel is way higher than the 12 volts your appliance wants, and that voltage can jump all over the place depending on the sun. You could seriously shorten the life of your gear, or worse, just fry it instantly. It's a gamble, for sure. Okay, so if the direct method is basically playing with fire, how do we do this the smart way? Let's move on to level 2, where we bring in a little bit of electronic brainpower to tame that wild solar energy. And you can meet your new best friend, the buck converter. This little gadget is the secret sauce for making a small, battery-free system actually work safely. Its whole job in life is to take that high, erratic voltage from the panel and step it down to a nice, stable voltage that your electronics can use without, blowing up. And these things are awesome. You can use them to get a perfect 5 volts for charging your phone, or to run 12, 24, even 48-volt DC equipment safely. You can even use one to feed the right voltage to an AC inverter, which lets you run regular household stuff. Super versatile. But this is where you got to do the math, and it might surprise you. Let's say you want to run a little 80-watt AC water pump. You'd think an 80-watt panel would do it, maybe 100-watt to be safe. Nope, not even close. Once you factor in all the little losses along the way, you need way, way more solar power. To reliably get that 80 watts out the other end, you have to start with a whopping 640 watts of solar panels. Why so much? Well, first off, panels almost never give you their full rated power, and that's before we even start losing energy in the system. So first up is our buck converter. It's pretty efficient, maybe 90%, but that's still a 10% loss right off the top. So our 640 watts is immediately down to 608. Next up, the AC inverter. Here's the kicker. That inverter uses power just to be on, even if it's not running anything. We call that idle consumption. So a chunk of our power gets eaten up right there, leaving us with about 473 watts. And finally, the inverter itself isn't perfectly efficient when it's changing that DC power to AC. You lose another 10% or so. So after all that, our huge 640-watt array gives us just 445 watts of usable AC power. It's more than enough for our 80-watt pump, but man, you can really see how those losses stack up, right?
So it's really about picking the right tool for the job. A buck converter is like a light switch. It gives you a stable, fixed voltage, on or off. But then you've got something called a PWM controller. Think of that more like a dimmer switch. It's got a little knob that lets you vary the power, which is absolutely perfect if you want to control the speed of a DC fan or a pump. Okay, so that's all well and good for smaller jobs. But what if you need some serious power? Let's crank it up to level 3 and talk about the heavy hitters, high-power systems. For big jobs, like pulling water from a deep well, you can get these specialized large pump controllers. The genius here is that you use a powerful DC pump, which means you get to skip that whole inefficient DC to AC conversion step. The whole system is way more efficient, and you can even set it up with a float switch so it runs automatically. But what about the ultimate challenge, running big household appliances? For that, you need the big gun, a hybrid off-grid inverter. Now, the key here is that it has to be a model that's specifically designed to work without batteries.
And that golden rule we talked about, it still applies more than ever. Your solar array has to be pumping out more power than your appliances are using every single second.
So just how much power are we talking about? Well, with the real-world setup, using a specific Growatt hybrid inverter and 10 panels, you could generate a massive 3,650 watts of clean AC power. That's enough to run some serious power tools, maybe even a small air conditioner.
But what does that kind of power cost you without batteries? Well, just for the inverter and those panels, you're looking at around $2,400. And that's the big trade-off. To go battery-free at this scale, you have to make a pretty big upfront investment in a ton of solar panels.
Okay, we have covered a lot of ground here, from the super simple and risky all the way up to the complex and powerful. So let's bring it all home. In Level 4, let's figure out how you can choose the right path for what you actually need.
But before we get to the final summary, here is a super important, kind of ironic tip. You see, things with motors, like your fridge, a fan, an AC unit, they need a huge burst of power just to get started. A system with zero battery storage can really struggle to deliver that kick. So, weirdly enough, adding even a tiny, small battery can make your battery-less system way more reliable.
And this right here is your cheat sheet. Let's break it down. Direct connection? Only for simple motors, where you're okay with the risk. Need safe, stable DC power for USB or other electronics? Buck Converter is your answer. Want to control motor speed? Get a PWM controller. Pumping lots of water? A large pump controller is the specialized tool for that. And for the big household stuff, you'll need that expensive hybrid inverter. Every method has its perfect use case and its own big drawback.
And that brings us to the final question you have to ask yourself. Knowing what we know now about the costs, the complexity, all the calculations you have to do, is going completely battery-free always the smartest move for what you need to do? It's fascinating that it's possible, for sure. But is it practical for you? That's something to really think about. Thanks for tuning in.